last state, that last current state, if it is one of the accept states, in other words, with two circles, then the decision it outputs will be accept. Right? That's why, now you know why this state is called an accept state. An accept state is one, if it's a final state, that means after the complete input string has been read, after the last symbol in the string has been read, it's called, that state is called an accept state if the automaton outputs a decision that is accept. Right? So accept states, if they're the last state, after reading the whole string, an accept state will output a decision accept. Okay, hope that's clear. I hope it's starting to gel a bit, to crystallize. All right. Now, if your last state, the current state of your automaton, it's now, imagine it's read the whole string. It has read the last symbol in the string, and it's in a given state. If that state, that final state, is not an accept state, it's not a state that has like two circles. If that final state is not an accept state, then the automaton, M1 for example, will output reject. Okay? So in other words, if your final state is not an accept state, the automaton will output the decision reject. Okay? Alright. Now I've run out of board, so we'll have to continue this on next session. But we can start a concrete example where our automaton we're talking about is M1. In other words, it's this, right? It's this automaton. And our input string, the language of our input string is the binary alphabet, right? So there are only two different kinds of symbols in that alphabet, 0 and 1. Okay? So our string is made up of binary alphabet symbols, in other words, zeros or ones. And here's the string, okay? Just four, it's a string of 4 symbols. So 1, 1, 0, 1. So that's the string that goes into the automaton, M1. Okay? So I'll go through it sort of verbally, and then we can do it in more detail this and the next session. Now, so we look at this, and we look for the detached arrow, if you like, coming out of nowhere. Here it is here. So we know the starting state is Q1. Okay, so we start in Q1. All right. Now we look at the first symbol. It's 1. Okay. So from the state transition table, or just this state diagram, we can also do it. So if Q1 and input is 1, this transition, then go to state Q2. Okay. So now I'll put my finger for the position of my finger is now, this here is this. Well, no, I'll use 2. Left hand and right hand. So the current state is what my finger's pointing at is we're now in state Q2. Okay, and now we look at the second symbol in the string, and that's a 1. And so we follow this transition because it's labeled 1, and we go back to Q2. So that had no effect, right? So we're still in Q2. Current state is Q2. Now we look at the third symbol in the string, and it's a 0, and so we follow this transition. Okay, and that puts us into state Q3. So we've made a state transition. We've transitioned from Q2 to Q3. Now we're here. We're in this state, Q3, right? And now we look at the fourth symbol, which is a 1, in the string. And what do? Well, if it's a 1 here, so we follow this transition. So we're back in Q2, right? And the automaton, it's assumed, has a way of detecting that it's finished reading the string. Right? That's the end. And now it makes a decision. Right? It's finished reading the string. It looks now, what state is it in? Is it in an accept state or not? If it's not in an accept state, it will output reject. If it is in an accept state, it will output accept, the decision accept. Right? Well, look, this is our final state. You know, this is the end state, the last state, after it read the last symbol in the string, the input string. Okay, and it's Q2, and that is Q2 is an accept state. In fact, it's the only one. There's only one accept state in this very simple automaton. Okay, so it is an accept state. So this automaton will give a decision of accept. All right. So summarising a bit, this automaton with this input string will give a decision accept. Okay? So there is something about this string that is acceptable to this automaton. Okay? Now that's a sort of hint, a clue to what's coming. It looks as though this automaton is filtering certain kinds of strings, input strings, from others. So it's sort of its job is, in a sense, to filter or to distinguish certain kinds of input strings from others. So presumably this automaton implicitly is operating on some kind of rule that accepts some strings from others, or alternatively is rejecting some strings from others. So maybe there's a whole bunch of different strings, different input strings, that get accepted by the automaton, and there's a whole bunch of other strings that get rejected by the automaton. Now, if you've got that bunch of strings that get accepted, you put them in a set, you then have a set of strings. Now, does that ring a bell? Can you remember some technical term that got defined as a set of strings? Remember? Alphabet. It's an alphabet. So, what is an alphabet? It's just a set of strings, and you can define any alphabet, right? So, in a sense, this automaton, or any automaton, is an alphabet detector. I mean, think about it, right? So take any two sets of strings, input strings, two sets, we'll call set 1 and set 2. So any string in set 1 will generate the output from this automaton accept. Okay? So all those members of that alphabet get accepted by your automaton. And in set B, any input string, any member of that set, which is input string, if you input that string to your automaton, M1, it will reject that string. Okay? So in other words, it rejects every member of that set. So now that set of strings is called an alphabet. So you have two sets, you have two alphabets, right? So whatever alphabet A is, this automaton will accept it. And whatever the alphabet B is, that automaton will reject that alphabet, because it rejects every member of that set, every member of that alphabet. So you can look on as an automaton as an alphabet detector. Okay? So I'll leave you with that stimulating thought.